virtualization is a concept which actually not a new one. We were in that age, and from there we moved into distributed system, and after that virtualization comes into picture, because mainframe actually it's a concept of virtualization. It's a single hardware. In that you are going to take multiple terminals. In that you will be running multiple processes, and you will be accessing that via the terminal, right? So that is the core system design in the beginning. And after that we moved into distributed system, and we started using the concept of the mainframe and how to run multiple operating system, or how effectively I can use the complete hardware to the fullest core of usage, right? That is where virtualization comes into picture. And this all starts with some basic concept like, normally a server at any point in time, the average utilization of a server will not go beyond 30%. Very rarely you can see on the peak time it is going beyond 60 or 70, or otherwise on an average it will be using 30 to 40% max, and the rest 60% which is going to sit idle. Okay, so that is where people started to utilize virtualization concept with the help of a hypervisor. Okay, to make the virtualization work, what people will normally will do is, we will have a underlying hardware. On top of that, they will put a operating system. On top of the operating system, we will be installing a hypervisor, and on top of the hypervisor we will be installing a guest operating system. So it can be any operating system, like if my underlying operating system is Linux, and over the hypervisor I can install both uh, Windows or Linux operating system on top of it. On top of the guest operating system, I'm going to install my binaries and libraries. This is where I'm talking about my application servers. Like it can be Apache for web servers, or it can be my MySQL for my database server, or it can be a Informatica for my ETL. Okay, or it can be my Selenium for testing the application. So it can be any scenario. Okay, on top of that you are going to put your custom code on top of it, right? Like over IIS you'll be installing your web page, or Tomcat you'll be installing your Java application. In Informatica you'll be uploading the Informatica code, or whatever it can be. So you'll be doing that. So this is what the virtualization concept comes into picture. In virtualization, majorly there are 4 resources which will be shared between these operating system. These are compute, that is CPU, and memory, that is the RAM, and then your network resources, and also your storage resources. Okay, so when the virtualization industry or virtualization concept comes up, okay, so they call it as a type 1 virtualization, and currently we are in the era of hardware assisted virtualization. Okay, so in the type 1 virtualization there were limitations, like my operating system should know, okay, I'm running on a virtualized hardware, so that I will translate the instruction so that my hypervisor can understand that and give it to the hardware, and the hardware can react for that. So those kind of limitations were there. Because of that we get to have the performance issues on the virtualizations, like because of the latest technologies like VTX. Okay, you mean to know, like Intel has developed this VTX technology. So as these kind of technologies comes into picture, where without modifying anything in the operating system, the operating system itself knows, okay, I'm running on a virtualization, and if I want to communicate to the underlying CPU, I should use this method with the help of hypervisor. So that is what kind of was happening, and the virtualization was growing in a very good way, and there are lots of effective utilization of hardware was happening. Okay, but there was a flaw in this architecture, because imagine I have one operating system. Okay, on top of that I have a hypervisor, and I'm unwantedly having one more operating system, which basically brings me one layer of processing before the request reaches to the operating system. Instead of that, okay, what if I can have my application, my binaries can directly communicate to my host operating system. Okay, it's very simple, right? Like I have a kernel, on top of that I'm putting another kernel, on top of that I'm putting my application. Instead of that, why can't is there a way I can allow my application to directly communicate to the host operating system? That is where the containers concept comes into picture. So in containers, it is something like it is going to remove one layer from the virtualization architecture, where instead of having the guest OS, my containerization platform allows my application to directly communicate to my host operating system.